Hey everyone, I'm TJB Chris. Thanks for watching. Welcome to Exploring Network 3. Today we're going to follow on to a couple of videos I did as part of my Tandy 2023 presentation on Tandy's educational offerings, particularly as they relate to the TRS-80 line. And we're specifically following on to two videos that I did there where I did a little bit of discussion about Network 3, what it was, and how it was implemented with Model 3-4 systems and supporting software. Today we're going to take that one step further, and we're going to dive into what makes the controller actually work. And to do that, we're actually going to realize a configuration that was promised both in the hardware manuals for the Network 3 controller and also in the first 1982 catalog in which the Network 3 was listed, which I believe was RSC7. And that configuration is as follows. Connected to the host or central port on the Network 3 is my TRS-80 Model 12. I think this guy's the granddaddy of the channel. It appears in more videos than any of my other machines, I think, at this point. I love to use the Model 12. It's a great machine. In the next corner, connected to one of the station ports, is my 64K D-board color computer, upgraded to 64K with matching CoCos SDC. And in the next corner we have a Tandy 64K Color Computer 2 complete with 6847T1 and CoCos SDC, if I can get my acronyms right, acting as disk drives. So that's the hardware we're going to be working with today. I've also got my oscilloscope off to the side, and you can see that the patient here is already in its gown. IV lines are wired in, she's ready for exploratory surgery, and we're going to dive right in. But before we do, a very important message about time. This controller was released in 1982. When it was released, the Deluxe RS-232 pack for the color computers did not exist. In fact, it didn't show up until the 1984 catalog with an availability date in the US of October 30th, 1983. Why is this important? Well, because I'm going to say rather definitively, as will the documentation that we're going to look at, that the color computer isn't going to support certain things. And it doesn't have certain hardware control lines on which the Network 3 relies. And of course you're going to say, well, TJB Chris, the Deluxe RS-232 pack, of course it did, you just had to get one of those. Well, not in 1982, you weren't doing that. So, when I say something final like that, or definitive, or the documentation or catalog does, do me a favor and put on your best 1982 hat and just transport back to a time when the Deluxe RS-232 pack didn't exist. Okay, with that in mind, the flow of this video is going to be pretty much as follows. We're going to take a little aside here, and then I'm going to focus on SIO programming for the Z80 SIO subsystem on the Model II-line systems. That's important because in order to work with the Network 3, having read the service documentation, I need to have a pretty good command of the SIO system and interfacing with the serial ports, which is a bit of a different beast on the Model II-line systems. Then we're going to talk about what it takes to actuate the controller, what it is, how it works, and finally, we'll do some serial communication from host to the various stations and demonstrate that. And again, this is a hardware-focused video. I'm not writing software for slinging files and programs and things around yet. This is a crawl, walk, run operation, and crawling is figuring out how the hell this box works. And actually, it's relatively simple and very well documented. Oh, and speaking of which, hello from over here. It's very important to note that the documentation for the Network 3 uses some terms that are no longer acceptable in today's technology vernacular. I'm not going to say them, but they are there. I did not write them. If you watch this video, you're going to see them. It was a different time. I am not sad to see those terms leave the vernacular. They didn't really belong there in the first place. We had the words primary and secondary back then, but whatever. If you will find yourself upset by these words, I didn't write them, but for the sake of using the service documentation, they're going to be on your screen. Okay, with that in mind, let's get back to the fun. And before we get to the fun, I've had a number of comments over the years about some of the great little knickknacks and other things that kind of adorn my computer room here. All this various stuff that I've accumulated over the years. Some of it retro computing related, some of it old technology related, some of it just there. But there's always been some sort of commentary for it. Some of it's even just practical stuff like these drawers, atop which sits a cool sign I got for Christmas. The sign reminds me of like old bank signs in the 80s. I love it. Anyway, I've gotten a lot of cool comments on a lot of the cool stuff that's in this room, and it turns out we now have a little more fun to help adorn the room. So recently I had the pleasure of meeting Alexa, and Alexa was nice enough to get us this really cool set, three-piece set of interlocking bricks that are assembled to resemble retro technology. In this case, a Nintendo Famicom, who normally sits right up here next to Super Mario. And of course, it does not have the Nintendo trademarks on it. It is, I'm pretty sure, not licensed, but who really cares? It's really awesome, and it was fun to put together. Next to it, we have a little Macintosh clone makeup here. This little mock-up of a Macintosh, not makeup mock-up. Can I open it? Can I open it? Yes, I can. Even comes apart to reveal innards and guts. Such a cool thing, and fits right in with the theme of the room. And finally, over here on my Radio Shack Rack-O Hi-Fi, I have a boombox, a teeny little boombox with an antenna that you can move, and a little tape drawer that opens, and inside is even a teeny tiny cassette that you can take in and out. Of course, placed over with the rest of the electronic audio equipment that I have. Very cool gifts. I'm really appreciative of them, and they fit perfectly within the room. So thanks, Alexa, for those. They're really awesome. I really appreciate them, and they fit in perfect here in the room, so thanks again for giving them to us. We really enjoyed meeting you and really love the gifts. Okay, moving on from that, I wanted to get that done because that way you're not stuck watching me dig around into a Network 3 controller with an oscilloscope and a Model 12. For the rest of you who are, though, let's get right into that now. So what is the Network 3? What actually is this box? We know it was used to share expensive system resources with less expensive systems, but what exactly is it? And I guess in my mind, I would call it a multiplexer demultiplexer. It's a one-to-many, many-to-one relationship for allowing a one, the host, to talk to the many, the stations. Now, I'm guessing, or betting, I should say, that that definition isn't purely technically correct because there's a more strict definition of what a multiplexer is. But from a high-level concept of one-to-many, many-to-one, it kind of does fit that bill. So I've kind of thought of it as a serial multiplexer, even if that's not 100% technically correct. That said, I got a really good definition handed to me for what exactly this thing is, and that was actually done in response to a Facebook article I posted on this. And Mike Yetzko, in replying to it, he always has so much great stuff to say about various handy things that when I or other people come up with projects like this, I always get some great info out of him, but this is my favorite one. He calls it a big digital rotary switch. It attaches the host to a single terminal one at a time. The host controls how that attachment takes place. If you write the software, it can do anything you could do if you were sitting there with a bunch of serial cables and could unplug and plug them by hand from the host machine, only at warp speed. And I can't think of a better or more succinct definition for the Network 3 than that. So that's really what we are. We're talking about a box with signaling from the host to allow it to select stations or possibly select them itself. We'll talk about modes in a second, but essentially cycle through each of these student stations and make sure that any student requests were serviced by the host. It's important to note, as Mike's post noted, and I think I've already mentioned too, this is a one-to-one communication. There's no broadcast. Whichever station is selected has the focus of the host. No other station can talk to the host or any other station. They're islands unto themselves until they are selected by the controller. So let's talk about the modes of operation for Network 3, and then we'll talk about how student selection is actually performed. All right, now with the controller sitting here in manual mode, let's walk through the various scope probe ports so we know what we're looking at as the scope changes. Port 1 is, or probe 1, is the yellow probe, and it is connected to test point TP10 within the network controller, and that it represents a 10 megahertz clock signal that is used for the automatic mode. We'll talk about that. Probes 2, 3, and 4, those are purple or lavender, blue, and green, are connected to the dataset ready pin of the various student station ports, particularly ports 1, 4, and 16. And, funnily enough, port 16 is the port to which the gray Color Computer 1 is connected, so that'll be useful later. Since the CoCos is only using its bitbanger, DSR was left out there and available and I could look at it. Why dataset ready? Well, DSR is actually the pin that the controller uses to inform the student stations that they are the active port for service. So if they have a request they want to get out there and they're one of the machines that uses the handshake lines, not the Color Computer, then that's where you would look to see if it was your turn. Since the Color Computer doesn't support that line, I'm mainly using it for a reference here, but it is in fact what it does. All right, so with that in mind, knowing that we have the DSR pin on the student station signaling when the stations are selected, I'm going to go ahead and talk about the modes on this thing. The first mode is the mode we're currently operating in now, that is the manual mode. In the manual mode, the mode indicator is not illuminated, and the host machine is responsible for signaling the Network 3 when it wants it to move from station to station. The Network 3 does go sequentially from port to port in order to select the student stations. 1, 2, 3, 4, 5, all the way to 16, and then cycles back around to pin 1. With a couple of exceptions, or really with one exception, there is no way to directly select a station port. You've got to cycle through each of the ports to get to the one you want, and that's a point that's made clear in the service documentation. So there's not a direct addressability, and in fact, the host machine has no direct knowledge from a hardware standpoint of which port is selected. It simply has to keep track. So you've got to hope that you don't get out of sync, but that's where the little caveat I talked about with direct port selection will come into play later. All right, so with the button not illuminated, we're in manual mode. I'm going to push automatic, and you can see that the scope is now changed. Now, of course, because I have my other lines here locked on, I've actually got a better view of that clock signal, that 10 megahertz clock signal. And you can see that the ports, the lines for channels 2, 3, and 4 are active for a short interval across the entire period here on the scope display. And those, again, are ports 1, 4, and 16. And their order on the scope screen doesn't really matter, other than to say, actually, just by virtue of the way that I kind of have this thing positioned, it looks a little off. But actually, let's just, if I do it this way, this is actually a more representative view here. You can see the green on the left there. I'll just do it for the far left side of the scope. Come on there. There you go. You can see the green, and then which is port 1, and then port 4, which is the blue, and then the purple, which is pin 16. And that's why if I zoom this back in, it looks as though the two are occurring right next to each other, even though the scope is not connected to two neighboring ports, but in fact it is. Ports 16 and port 1 are directly connected. If I release the automatic mode, of course, whichever station was currently selected remains selected, and the scope goes back to crazy town because it doesn't have a good lock, so the clock is just rolling around in the background there. Interestingly enough, even in the automatic mode, it is in fact possible to stop the automatic controller host selection. How is that done, you might wonder? Well, that's actually fairly simple. I can set DTR to low, and now port selection stops. As soon as DTR goes low, port selection stops regardless of the mode button. Okay? So if I want to get that going again, 300, and now you can see the controller is back to cycling through the ports. And again, each time it gets to a particular port, it brings DSR high on that particular student station's port, and the student station should know that it is active. Well, that creates a little bit of a conundrum, doesn't it? Because the color computer doesn't have DSR. Again, 1982. So how does it know? Well, in fact, that's why the color computer wasn't originally supported, or doesn't support the automatic mode, I should say. Documentation clearly states that the color computer cannot be used in automatic mode, and now we know why. The 4-pin bit banger does not have the DSR line, and therefore there's no way to signal to the CoCo that it is in fact its time to talk. Which means, as far as I can tell, the only way you're going to be able to deal with the color computer on this thing is to pull it from the host after selecting the student station. But that's the subject for another video and software. We're talking hardware today. Either way. That's how that works. Okay, so what about the manual mode then? What does the manual mode do? How does it work? Well, let's take a closer look at the manual mode. Oop. I'm going to disengage the automatic mode here, and we're going to take a look at what we've got. And now this is where I have to get into SIO programming. We're going to talk a little bit about programming the SIO on the Model 2 and what that takes. All right, with my screen visible here, you should have a pretty good view of the text on my Model 12 screen. And as you're looking through this program, I want to be clear, this program is really a stream of consciousness for me. It's not a full-fledged put-together program so much as it is, in fact, just my notes and working through this. And this is the simpler of two programs that we'll be looking at today. And basically, the way that the SIO programming works, the Z80 SIO chip supports 2 serial ports. And hence why the Model II-line systems have 2 serial ports. And each one of those ports, as you can see by the documentation over here, has a pair of registers. One is a data register where data is read to the serial port or read from the serial port. The other is a command and status register where the SIO chip is programmed and its status can be obtained. In order to operate and program the SIO, for example, to set DTR high or DTR low, is actually a 2-byte operation. There are 7 write registers on the SIO for the command registers, and those registers program different aspects of the serial interface. With the write registers up on screen, you can see that there are different bits and different registers for programming the Z80 SIO chip. Specifically, for example, write register 5. If I want to bring DTR high, that's bit 7, assuming a 0 base on the bit numbering. And that means that I have to AND a value of 128 in. Now that's in addition to any other values that I want. So for example, if I want the first bit highlighted 2, I have to make it 129, etc. And again, I can set that by doing a 2-byte operation. The way that this works with the SIO is you send a byte to the command status register indicating the register to which you'd like to write, in this case register 5. And then you send to that very same port the value of the data byte you'd like written to that register. So in the case of line 310 here, we're writing the value 128 to the SIO write register 5. Similarly, down here on line 340, we also reselect register 5 and then we write the value of 0. Now, it's important to note that register 0, which is really the command register in the SIO, does have some possible configuration mainly related to reset that can be done as a 1-byte operation if you want to reset the thing. So taking a look into another example here, we've got, we're writing register 4, and we're actually writing the value of 4, and that's no parity 1-stop bit. And then down below it on line 114, we're writing to register 3, the value 193, that's 8 receive bits, receive enable. Once I've configured the SIO the way I want, I can read and write from its matching data port for the SIO channel in question. In this case, I'm using channel A. You'll notice something if you're looking closely at this documentation that's missing though, and that's a baud rate. There is no baud rate. If you take a look at register 4, you'll note that there is a clock multiplier, but there is in fact no direct baud rate setting. How does that work? Well, it turns out that the SIO chip actually works together with something called the Z80 CTC, the counter timer chip. And I'm going to load a more comprehensive version of my little prototype here so you can take a look at how exactly this interaction works. And now I'll tell you that for my SIO programming, I did all the SIO stuff myself except for figuring out the clock multiplier, and I'll talk about what I did. For the CTC side, I started reading the documentation and then got antsy, so I kind of cheated. We'll talk about that. Okay, here you can see I have two sections here. Line 360, I start my CTC in it, and line 400, I start the SIO in it. How does this work? Well, it turns out, as I mentioned, there's a clock rate here called out in line 420 with an X16 clock. The baud rate is a function of a signal frequency generated by the CTC, then multiplied by the clock in the SIO to come to the final baud rate. This takes a little bit of practice to get working. So I cheated a bit. After figuring out the SIO portion of this and deciding I didn't really feel like diving into the baud rates because now that I had command of the SIO, I just wanted to see this thing do stuff, I set up a copy of my favorite TRS-80 emulator, TRS-80 GP, an emulator you should totally set up and use for stuff like this because TRS-80 GP has a debug mode, and that debug mode, that debugger I should say, has a trace. And you can trace the CTC and SIO selectively and together so that I could basically configure the serial port using TRS-80 native software and not have to dig too deep into it, and it told me the answer. In fact, it was so well organized, the trace, that it even calculated the baud rate that I was going to end up with my effective baud rate, which was really frickin' cool. And you're seeing that up on your screen now. That's the result of the trace I did too. The way that I ran that trace was I booted to Tristos and I ran setcom on serial channel A and watched it configure it. And one neat thing I learned about setcom is it configures both serial channels even if you only specified configure one. Anyway, that's kind of an interesting little thing. So what I did was I figured out the baud rate and multiplier that I needed for the SIO to be able to talk at 300 baud. Why 300 baud? Well, 300 baud is necessary because it is the speed at which the bit banger on the CoCos is going to play the nicest with, and for any terminal programs I'm going to use, it's going to need to be able to talk at 300 baud. So I stuck with 300 baud, it was safest, and again, it'll work with my terminal programs and the color computers. So we're starting small here, folks. Again, crawl, walk, run. All right, so now that we know how the SIO is programmed, and again, this is a crash course in Z80 SIO and CTC. It could be its own video going into the SIO and CTC, but I had to learn this from zero, and once you get the hang of it, it's really easy and really flexible, but it is a little unique to the Model II-line system, so it's not quite the same as programming serial on these other machines. Not that there's a standard way to program serial on any of these things, but you know. So with that in mind, now that I have a configured serial port, let's put it to use and actually configure the Network 3. We've seen it in automatic mode, we've seen how it actually works, maybe I can actually do something to start to manually step through the Network 3 serial ports. And this is where the service documentation comes in really, really handy. Alright, back here with the Model 12 with my basic program backup, the oscilloscope down here, and the service documentation. Let's talk a little bit about the hardware handshake lines necessary to actually make Network 3 do things. And those are really boiled down to 3 different lines. That's data terminal ready, request to send, and dataset ready. Dataset ready, of course, we've already mentioned, is used for the student stations to know when they're selected when you're not a CoCo in 1982. And data terminal ready and request to send are used on the host side to control the actual Network 3 controller and port selection. So the first thing we're going to do here is I have on my screen, I'll put up to this program. And what I've done here is I've written a little program that checks for key input and then it does a couple of different things. But essentially what it does is, without any of these special keys, it steps through each of the ports, and I'm going to show you how each of those things are done. So if you take a closer look at the top of the page there on the service manual, you'll notice that there's a way to reset the controller back to port 1. And my program does that when I run it. So let's just give 110 a run. And there we go. We can see that the green channel, that's channel 4 on the scope, is selected. And that is the dataset ready pin of pin 1, now held high because the controller is in manual mode, and it has been forced back to pin 1 as part of my initialization. Now we can see, if we look down a couple of lines, that and by the way, that is the one exception to the you can't manually select a port. You can always jump back to pin 1, and that's sometimes necessary because it is possible for the host to lose track of where it is. Now let's take a look at the next one. How do I advance a port? Well, already you can see that it's a function of flipping the request to send line. So with DTR brought low, RTS at a logic high, if brought low and then high again, will signal the line. And that's exactly what will happen if I push a key here. So actually, before I do that, oh, well, I just did it because break did that. You can see though that my green line, I'm pointing at the scope and you can't see that, has now gone back low because it's no longer being asserted. But let's take a look at what's actually happening there. 200 to 250. If I want to toggle it up, I out 246,5. That's the command register to select register 5. And then we out 236,234. That brings RTS high. I then I out 246,5, and then I out 246,232 to bring RTS low. The act of doing that essentially flips the RTS line, causing the controller to advance to the next one. So again, if I run 110, we can see that, oh, line 1 is now high again, station 1 is now high. If I, must have been some good grass. If I continue to push it, it's going to write through, and I have the program written to write out bytes to each port it selects, whether there's a station there or not. And now we're about to hit pin port 4, and I just hit H for help, so that's not going to work. There we go, there's port 4, there's the bluish line active, and now 5, 6, 7, and again, there's no direct selection other than going back to pin 1. So if I want to go back to start, that's the only option I have. If I want to go here from pin 9, and I want to draw port 9, I keep saying pin, and I want to get down to 6, I have to loop it through 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4, 5, 6. It's not going to, now you can do that really, really rapidly, and I'll demonstrate that in a minute. I think port 12 is where the other line is connected, or 13. I don't know where I connected it now. Or the port fell out. Must have fallen out. There we are. There's 16. That's the Color Computers port over here. So that's actually the port that the Color Computer is connected to. And then we wrap right back around to 1. You can see purple went away and green went back. And that is essentially how Network 3 works. So now that we're here on port 1, what if I want to go straight to 4? Well, I can do that. I have an S key here. I've programmed into this, and I can say port 4. And you can see port 4 is now active, and I can select port 16. And again, it very quickly jumps up to port 16. How is that working? So here on the screen, we can see I've got my little subroutine for actually selecting a specific port. And the way that this works is really stupid simple. You already saw the portion of the logic that dips the RTS pin one time every time I just tap a key and cycle through them. All this does is wraps it in a couple of loops. If the port you're selecting is greater than the current port, then it will loop its way through and just go sub 540, or I'm sorry, go sub 210. 210 is where where the bit flip exists. Otherwise, it actually has to add the remainder of the ports from 16 up and then loop back around, so it calculates how many times it has to whack the RTS line, and then it goes and does it that many times by, again, go subbing to 210. That's actually how straightforward it is to select the Network 3 ports. It's really that easy. And again, if I run it now, it's going to set port number back to 1. Oh, that's the wrong one. It's going to set port number back to 1, and I can either sequence through it like this, just pushing any key that's not one of my special keys, or I can jump right to a port 16, for example. And as you saw, you may have seen very quickly there, when I did the port selection, let's do that again. I'm going to select 16 and watch as the blue line is going to dip up quickly, and then it's going to jump to 16. Did it very quickly, but it did do it. And let's just go back port 2 just to see if I can keep the scope's reaction time from getting in your way there. And sometimes it goes so fast the scope doesn't get it, but that first time around it did. The blue line popped up there quick enough. It didn't render it fast enough. But that's the basics of port selection on the Network 3. It really is that simple. So now that we know this, why don't we try and see if we can send some data back and forth to my student stations from my host. All right, folks, the screen's going to be a little dim on the Model 12. I've got the camera in manual mode so you can see the color computer screen. And this is actually pretty important because what I've got going here is Mickey term. Mickey term? I don't know which it is. Well, whichever it is, because like I said, we're focusing on serial communications and not software, and that's really what the heart of the Network 3 is, I wanted to focus on just getting bytes back and forth between the two, and so all I have to do is use a good terminal program. So let's do this. We're going to set up our communications parameters to match the SIO programming, which is 300 baud, 8 none 1. There's no baud setting on this unless you're using an RS-232 pack. Break, and we're going to go right to the terminal. Okay, so I'm going to hit the button here. As you can see by the scope, the green line is selected. That's port 1 on the controller. The color computer is plugged into port 16. So if I increment to port 2, it's going to send bytes out, but you're not going to see anything on the color computer naturally because the color computer's port is not selected. Now we'll do port 4. Now you can see 4 is high, but nothing's coming out. So let's send it right over to 16. 1, 6. Well, hello, you rummy buzzard. Now that port 16 is selected, we can send it bytes. And in fact, the SIO is really cool because the same Z80 port that I write to is the same one I read to get characters back, and there's a status register to tell me if there are any characters in the buffer, and it's really that easy. So all I have to do is say, hello to you too. And I should note that what you're seeing here, it's now on the screen here, is that the Model 12 is actually echoing back the CoCos characters. I'll show you that. So now when I select the color computer and type on it, anything I type actually echoes back. You know, la, la, la. All that just echoes straight back from the Model 12. And if I hit the button here to select port 1 again, yeah, see, nothing. I'm just typing on the computer, nothing's happening. And that's because port 16 is no longer selected. But you know what? I can just fix that by going right back to port 16. And again, as you may have seen briefly, the host has to cycle through each of the ports between 1 and 16 in order to select it. Now, of course, not done in BASIC, this could go much faster. In fact, I think the controller can support, on its 10 megahertz clock, I think it cycles through the ports about 600 times a second or something like that. It's a lot. So it can take a fair amount of high-speed port switching if you want. So anyway, once again, I can just say blah, and I can move on to the next port. Of course, the Model 12 got blah. So now what happens if I add another station to the mix? Let's get our Color Computer 2 rolling here, and we'll take a look at how that works. All right, so we can now see the Color Computer 2 is also running a copy of Mickey term, I guess. Michael Ward wrote it. And I'm using version 4.0 here. I did not have much luck getting 4.7 for the T1 to work without crashing, so I don't know what that was about, but it didn't play nice. Either way, we don't need no stinking lowercase. We'll be fine with the capital letters. As you can see by the scope, port 1 is currently selected. You're not gonna see the Model 12 screen here, just because it's not really gonna be practical to do it. And port 3, port 4, and of course no bytes are coming through. I think the CoCo 2 is connected to ports 11 or 12. So here's what I'm going to do. I'm going to cycle rather than have you just sit at a color computer while I cycle through these ports. I'm going to select port 11, which of course is not highlighted, and then I'm going to hit port, oops. Oh, that's not good. I accidentally got myself into a spot where I was selected port 0, which is a logic bug in my dumbass basic program. We're going to support 12. Here comes port 12. And it's not port 12. It's not port 13. Not port 14. Okay, Color Computer 2, which port are you plugged into? Oh, it's port 10, you dummy. Here it goes. There we go. Hello, you rummy buzzard. And I'm going to lean right in here and say, hello. And again, as you note, the Model 12 now says hello, and the Model 12 is echoing the characters back. So when I hit pin 11 here, or port 11, I've now moved on. Typing on the Color Computer 2 will do nothing. Typing on the Color Computer 1 will do nothing. But if I select port 16, there we are. And I've made an automatic mode that I'm going to see if I can get to show up on camera here, where the Model 12 will automatically cycle through all the ports, and you can watch as the scope kind of will, the lines on the scope will rise and fall based on which port is selected, and you'll get to see the Color Computers write bytes automatically without me playing into it. Let's see how that works. Alrighty, here we go. I'm going to hit, I believe it was A for automatic. Here I have a little help function. A for automatic. It's going to cycle through each of the ports and write the phrase, hello you rummy buzzard, automatically over and over and over again. You can see here when port 4 selects, we're going to have a blue line on the scope. And I, again, should remind you, the CoCos 2 is a direct cable connection with a soldered cable, so the DSR line on that one is not being watched. Here comes port 10. See, it's writing on the 2 over on the right. Now we're up to port 11. Isn't it great to listen to me narrate counting numbers, folks? This is riveting friggin' television. 14, and 15, and 16, the CoCos 1, and there it goes. And now we're back to port 1, and we've got a green line on our scope. And that's the basis of Network 3 in very, very slow, like snail's pace. And this may seem insignificant, but with this little formula in mind and the excellent service documentation, we actually have a pretty good platform, you know, or basis onto which we could develop something more meaningful. For example, could we use this to write a client program for the Color Computer that with a host that runs on the Model 12 that could feed Color Computer software down through the serial ports? So with this still running in the background, I thought that was kind of a fun way to explore Network 3. Again, I went through it fairly quickly. There's really not a lot to signaling the Network 3 controller. And again, the SIO stuff I could have spent a whole bunch of time digging into and talking about. The SIO is its own thing, but quite frankly, once you get the hang of it, it's pretty straightforward. If I'm just learning this, I'm new to it, but it is a really cool architecture for serial ports. It's a little more cumbersome to use than some, but it does add a degree of flexibility. And I did enjoy it gave me direct control with the command registers over the RTS and DTR lines, and that's really what I needed. So that was really freaking cool. And as you can see here, the Model 12 is, you may not be able to see it, but it's still scrolling. Actually, you can see it on the scope. I'm looking at my laptop screen now. One thing I did want to point out, because I think I overlooked it when I was talking about the systems that I'm using here, if you're going to do this on a Model 2-line system and you want direct control of the serial port and you want to play around in BASIC with training wheels, as I have, you're going to need to use CP/M and MBASIC or some other BASIC than the BASIC that comes with TRS-DOS. TRS-DOS BASIC does not have the IMP, IMP, and OUT commands used to do Z80 port I/O. This is frustrating, but it is the way it is. People complained about it then. There's a bunch of other stuff, I guess, missing from it too, that those of us who are accustomed to 134 systems kind of took for granted. But either way, CP/M on the Model 12, this is Radio Shack CP/M plus 3 on the Model 12, and I've loaded a copy of MBASIC on there, so I have my Z80 ports. It does lack a CLS command, but just print character $12, and that will clear your screen for you. Either way, this was a little bit of an exploration into Network 3 and a view of a configuration that we've never seen before. So I thought that was a fun little dive into Network 3 and how it works. As a controller, as you saw from the service documentation, everything I needed to know was on one page of the documentation. And in the page before that, there's actually a really good discussion for exactly how the controller works and what it does. But that page that I had up on the screen was really a good cheat sheet for how to actuate the Network 3. And actually, the biggest barrier for me was just spending a couple of days trying to figure out the SIO subsystem. And honestly, the part of the SIO itself without the baud rate where you just kind of diddle the bits, that was easy. I had that figured out day one. by figuring out the relationship with the baud rate and then deciding to cheat and use TRS-80 GP, which you should too. I just really wanted to see this work more than I kind of wanted to get into the willy-nillys of the CTC, but I figured I would share that with you. It is relevant, it was relevant to this project, and it would actually be relevant to anybody who decided to make a Model 2 host for these color computers. Another point I should make, this is a serial switcher. It's not, as you can see, it's not dedicated to the 134 systems, it's not dedicated to CoCos. You could connect Tandy 1000s to this, you could connect Apple IIs, Commodore 64s if you have a full-on serial port on your C64, anything you want. You know, so I could make a bastardized Franken network of all sorts of these machines, even if they were just talking over the serial port with like a simple chat program. One person did ask in the conversation about deload. As far as I understand it, deload predates the controller. It was an extended basic in '81. The controller rolled around in '82. But that doesn't mean that you couldn't necessarily get deload support over this controller. So I don't know if that's a project I'm going to take on or not, or try just to see if I can do it, but it is something of interest to me. So if I follow up with this again or do anything else more with it, which I do plan to in the future, I will do that. In the meantime, I am going to have another project with the Model 12 here. If you saw my card cage project last fall, the next piece of that is available. The card cage has been done for a while, but I now have the Tandy Emeritus backplane, and we're going to be assembling that in the coming weeks, and that is going to go into this TRS-80 Model 12. So, with that all done, I think that's where I'm going to leave this here. I hope you enjoyed this. I hope this answers some questions. If there's things you'd like to see me do with this, or any detail, anything I glossed over, or anything that you'd like to see again, please let me know in the comments. I promise this will not be the last of Network 3. For some reason, simple things overly interest me for some reason. And the Network 3 is actually a really simple thing, but it is a really cool thing. And it was used for a great idea, and it was really fun to see a configuration that was advertised as supported but never actually saw the light of day come to light. So with that in mind, thank you for watching, thank you for exploring Network 3 with me, and join me again next time in the Charles D. Tandy TRS-80 Emporium, where we'll be building the Tandy Emeritus backplane for the TRS-80 Model 12. Thanks for watching.